this is the essential for calculating arrays and everything. And half by half used pandas and matplotlib. And most of you uses Windows, and we have a few Mac and Linux in the same proportion. And from the open questions, we're going to use, we're not going to do any spectrum analysis because I think this is too advanced for today, but maybe we can do this in another course or something like this. We are going to cover using Spider notebooks, not Jupyter notebooks, but if you have a Jupyter notebooks, you can use your Jupyter notebooks with no problem. It's Jupyter notebook has all the packages installed the same as Spider. Can you train? We are not going to go deeply in eddy covariance because also the FluxNet data, we don't have the micrometeorological data. We have the fluxes processed, but and I think it's too advanced for today. But I'll put on the chat. We have an article in the FluxNet blog with many suggestions of softwares and programs for eddy covariance. So those who are interested, you can have a look here in the chat. We are going to have a brief introduction, Python, NumPy. I use MATLAB, so you can use, we don't need to switch. You can use, I think you can use MATLAB, Python, Fortran. But for remote sensing, we are not going to remote sensing here today, but I also going to put on the chat links for many packages and libraries for Python to use with remote sensing. You can find information on that sites. Flux-specific libraries you can find in the link. This FluxPart, PyFluxPro, HasFlux. These are on the article in the blog, in FluxNet blog. And Flux-centric Python packages. Maybe you can talk. We are not covered this today, but maybe you can talk a little with Lucas about this. Remote sensing you can find on the link. We are not going to deal with this today. I find many of CDF and large files. We are only going to use here today ASCII type files. And I think it's this. Also this PyTorch, it's artificial intelligence. We're not going to cover here today, but you can find, you can touch a little bit with this with Lucas. And we are going to plot color map, and let's go back to the presentation for you to go with Lucas quickly. So here's the program. You already I think you already have seen this on the program. And we are going to use, today we're going to use essentially two data sets from the Amazonian region in Brazil. The first one is mature forest, and the second one, BRSA3, is a cleared forest. And near Santarém, the two sites are near Santarém in Brazil in the Amazonian region. So for those who didn't download the data, we are going to do this here. I just want my computer to go fast. I maybe close this. When it go open, we can advance a little. Now here, now it's good. So to download the data, you need to be signed in the FluxNet portal. We need to have an account. So in the FluxNet portal, you can come here in the sign in and create a new account. It's quite easy. You just need to fill the some fields, and then you need to sign in. You need to sign in the portal to download the data. Then you come in on data and download data. I will show first how to download the data. For those who didn't download the data, you can start downloading, and when data is downloading, we can go advancing in data formats and other stuffs. So you can here on download data on the FLUXNET 2015 dataset and CC BY 4.1 data. And here I will say to you to select a full set to have all the issues that Lucas can work with many different things. You can select here the two sites, BRSA1 and 3, and select the BADM's also auxiliary files. And in terms of use, you can choose teacher, student, and then you can fill here using the workshop and start download I recommend you to read the FLUXNet data policy and then download the data. So for those who didn't download yet, and when the data will be downloading, and we can do a brief description about the data types and formats. So the FLUXNet 2015 dataset, it's composite from multiple regional flux networks from all over the world. And the previous versions were FLUXNet Marconi dataset 2000 and FLUXNet Latwil dataset 2007. And the FLUXNet 2015 datasets include several improvements to the data quality control protocols and the data processing pipeline. And to do these the new improvements, the management project team work in close interaction with tower teams to improve data quality, new methods for uncertainty quantification, use of reanalysis data to fill long gaps of micrometeorological variable records, among others. You can find all the description of how this dataset was made and the techniques for this in the reference paper by Pastorello et al. And the name of the article is the FLUXNet 2015 dataset and the one flux processing pipeline for eddy covariance data in scientific data paper journal. So we have under the data policies, we have two kinds of data policies in the FLUXNet 2015 dataset. The CC BY 4.1, previously tier 1 type. It's the data user is free to share, copy, and redistribute the material, and or adapt, remix, transform, and build up on the material for any purpose. All this information is on the site. I just want to do a brief introduction here for you to know a little bit about the data you are going to use with Lucas. So the guidelines, you should seek the data collection paper and list each site used by its FLUXNet ID or per site DOI. It's recommended that data users inform data providers of forthcoming publications. The second data policy, more restrictivity, is composed by data available only for scientific and educational purposes. Data producers must have opportunities to collaborate and consult with data users. Substantive contributions from data producers reside in co-authorship. To publish research, data user must contact the data providers. Also have guidelines that you need to see the data collection paper, list each site used by its FLUXNet ID or per site DOIs in a table in the paper, if it is published. In case of synthesis using both two types of data policies, you should consider it treat all the study as a tier 2 policy. So we choose a full set for in simplicity here to download all the data available. So the full set package will have all variables generated by the processing, including uncertainty quantification variables, variants of the data products, quality information flags, variables generated by intermediate processing steps. So here you have the physical variables like meteorological and fluxes, latent heat, sensible heat, wind, precipitation, but you have also some flags and some auxiliary variables used for processing these data. In the second way to download data is choosing subset. So here it's a small size file. It's a selection of variables based on the expected usage for most users, accompanied by a minimal set of quality flags and uncertainty quantification variables. So people that want to do synthesis with many sites, you don't have to download a lot of stuff that you are not going to use. And together with the principal files, with the principal variables, you have the auxiliary files, like the aux-meteor containing results from the downscaling of micrometeorological variables using the ERA interim reanalysis data product, and the aux-NEE that contain variables resulting from the processing of net ecosystem exchange, mainly related to friction velocity filtering and generation of ecosystem respiration and gross primary production. That these are most time are calculated by the towers teams. So the temporal aggregation resolutions here, as I said, you are not going to find the micrometeorological data like the measured at 20 hertz, 30 hertz, 10 hertz. You are going to find the processed fluxes. So you have generated either half-hourly or hourly data sets. And these are the basis of and the finished temporal resolution provided in the FLUXNet files. With this, you will find another files with cursor aggregations are generated within the data processing pipeline. So you'll find files with cursor aggregations of daily, weekly, monthly, and yearly aggregations. And Lucas will show you that in pandas, when you have the finest temporal resolution, you can manage these and do these aggregations with many arguments like mean, sum. You can. It's easy to go for and come back from this type of calculations. So when you download the data, you have a zip file containing many files, and the data file's name is the first field is the publisher. So here's the FLUXNet symbol, the site ID, like BRSI1. The processing pipeline is the FLUXNet 2015 dataset. The grouping, you choose it, if a full set. The resolution of the data. So here on this site in Brazil, we have data from 2002 to 2011. And you have the site version and the code version. So it's 1 and 4. And when you extract this zip file, you will have many comma separate values files with the main files and the cursor aggregate files, and also the auxiliary files. The timestamps formats is in the format of year, month, day, hour, and minutes. And you have in a single stamps and a pair of timestamps when you have a time of start and a time of end, and the data will be the manipulated data in this period. And with Lucas, we'll see that in pandas, you can easily indexing these timestamps, and you can change the timestamp format, and you can do a lot of things with pandas timestamps indexing. The time zone of the data is the fuse of the time fuse of the local of the tower, and the column and in the column order of the files are not guaranteed to be the same for different files, different sites. So like when you do a synthesis, you need to take care in the column order, because like those who use Fortran and C++, we need to, when you have a data file, we need to count the columns. So if you are going to use column 4, you need to count. And sometimes when you have a file with 50 columns, it's quite difficult to count the columns. And with pandas, you just need to have the header. And if you have the header, you just call, you want the temperature, you call the temperature. You want the precipitation, you call the precipitation. It doesn't matter the order. So Lucas will teach you how it's easy pandas in this kind of applications. And the missing data indicated with minus 9999 in FLUXNet data files. And also Lucas will show you how in pandas you can replace this with none or with NumPy none, putting this in a calculation format adequately. So thank you. Sorry about did this not so quickly. And now I want to introduce Lucas and Raphael. I forgot this, but my research is on interactions between soil vegetation and atmosphere modeling, focusing on vegetation dynamics and physiological vegetation processes with particular attention to turbulent transfer coefficients and respiration processes. Lucas is working with hydrology on water balance estimation using mostly the AmeriFlux dataset and partially remote sensing data. So a lot of, I saw many of you interested in remote sensing. Lucas will quite provide you some information in this. And Raphael research is focused on physical limnology and environment fluid mechanics with a major interest in the hydrodynamic of stratified flows, specific internal waves and gravity currents. So now I will pass you to Lucas, and he is our specialist in Python, and he will instruct you in the main course. And as I said, as Raphael are not going to be here today, he recorded a video. If you want to go further with Lucas, you can manage this with him, and we can send you the video from Raphael for you to attempt to matplotlib at your convenience. Thank you.
Andrea, Lucas, just a quick note. Do you guys want to open a quick 5-minute interval for questions, just to check if anyone has any questions?
Yes, of course. I'm trying to stop sharing my screen.
What can I'm trying to figure out how to raise my hand. I do have a question though, because I haven't used FLUXNet data like on this great of a scale. I do work with folks who are applying Flux data, and I have a hard time differentiating what I can use as is that I've downloaded from FLUXNet data sites, and then what needs further like gap filling or attention. I'm hoping someone with more experience can kind of help flesh that out for me.
Lucas, can you take that? I think I will need to disconnect and come in again because I'm not being able to stop sharing my screen.
Okay. I'll help you. Give me just a sec.
Okay, thank you, Gilbert.
Please, I really don't understand completely your question because I'm hearing not so good, but
sure.
Please.
Yeah, I can repeat the question really quick. So say I've downloaded all of the FLUXNet data that we have today. What variables should I be cautious about simply using in an analysis before doing any sort of review of the data, right? Like checking the histograms or the time series. What things should I be responsible for sort of editing or gap filling, and what is ready to go?
You would like to see, to know how variables is good, should be gap filled accurately? I don't know.
Yeah, so what data variables in the FLUXNet set can I use immediately, and what variables should I have good data management practice with, right?
Okay.
And double check, so to speak.
I'm not specialist in all variables present in the FLUXNet dataset because there is a lot of kind of data, but in general, I think Flux's data must be like age, LE, or G, RN should be looked at with more careful, because Flux's data it's I don't know what the word, but it's more special. I don't know, it's the word. Temperature and maybe precipitation, or maybe relative humidity can be used, I think, in many situations immediately, because it's more no variables measured and older measured, you know? But on the other hand, Flux's data are pre-processed, so it can be when you see a gap in this data, maybe this data, okay, it's a gap. Let's see what we can do. If this data was not excluded of the file, maybe I can use. So it's a compromise situation, and I think you should see case in case.
Mm-hmm. It's case by case.
I think it's not a closed answer for that.
I can add a little bit to that, to Lucas. Thank you for the introduction there. So all of the variables in the data set, they are also accompanied by a quality control flag, and that quality control flag indicates how good the data is. So in most cases, the levels will mean something like this was measured data and considered good quality, so it was kept as is. And then for everything that's missing because of either a sensor failure, and I'm seeing a question from Leila here that is along these lines. Data can be missing for many reasons: a sensor failure or an outlier detection algorithm removed that record. So we do apply the gap filling algorithms for all the variables that make sense. And all of that is reflected in that QC flag. So every time that you're using these variables, also look at the corresponding QC flag, the quality control flag, because that will give you an indication of how good and how blindly you can trust on that. I never trust data blindly, but how much can you trust that data set, right? Yeah, as Lucas was saying, the flux variables, they have a more complex processing pipeline. There are many steps that are applied to get to the final flux. So that will mean that you need to take extra care when using those variables. And you should always know that the gap filling algorithms are never perfect. So you should always take that into account in your analysis. Make sure that the gap filling is not introducing any type of bias in your analysis.
Yes, and Gilberto remembered me that some columns on the data, for example, LE, and LE have an underline F, and this data is the same data of LE, but when the gaps was filled by the team of that work on the tower, so it can be more the word more, you can confidence more in this data because the tower team know what happened in that situation, so you can use this data with more confidence and not the other. We are in we are answered the question yet, or I can start? I don't know.
Yeah, I think you're good to go.
Okay. Okay, so thanks again. Let me share the screen. Please be patient because I do not use too much the Zoom, just Google Meet. let's see, you are seeing a full data set here, I think, on my share screen. Okay, let me. Nice. Where I am here, so okay. Quickly, presentation. This is our favorite lake in Curitiba, Brazil. Let's see. So, my name is Lucas. I will present to use the using of pandas and Python for processing the data in a relative complex data set like FLUXNet data. So firstly, thanks for the invite. Thanks especially for Andre that called me for this presentation, and everybody involved in this organization. You can send me, this is my email. So if you have further questions after the presentation. I think all of you are here because Python is a good language. Everybody heard about Python sometimes in your life and heard good things about it. And the first advantage is that Python is a very, very simple language to learn programming, because the variables are very, very simple. You not to need to declare the variables like Fortran or C. You can manage every kind of files and every kind of variables with Python. So this is very, very easy and robust language. But of course, this is not the best language in the world. We have advantage and disadvantage. Some disadvantage that for you, if you want to run a numerical model, for example, you're not using Python because he a little bit slow for this kind of situations, because the variables is not declared, so it consumes more memory in some cases. But for reading different kind of files and reading files that contains a lot of types of variables, it's very, very easy using Python. Python is an interpreted language which allow us to code faster. So we cannot, you not need to compile the fast, you not the code, you not need to do a preparation. We can start, make some tests, test issues, and update your code, which you call script actually, and you can run it in live, if I can see. And pandas as part of Python is even better, because it was created just for thinking in data processing, not just numerical data processing. We can use pandas, for example, for population survey or things like this. So it's a very useful tool. So my presentation is very, very quick, because I will show you the things in real time. So if you want, you can open the spider that we instructed on the. Let me see the time. So instructing the tutorial, and let's see some things. I will do a little presentation of Python, because on the survey we saw that a lot of people here are using Python or use Python, but I don't know if it's a deeply user of Python, so I will do some introduction on variables, on and how to think the basic stuff on Python, and you can go to pandas, because of course pandas is part of Python, so maybe I think it's important to see. For people that already use Python a lot, this first part can be a little bit annoying, but I will be patient, please. So let's see. When you open the Spider, Spider, it's a tool made exclusively for Python. We can run Python using another kinds of editor, text editor, like I don't know, Notepad, Notepad++, or Genie, or everyone else. But it's interesting to use some tools specialized for this. So Pandas Spider is a good tool for that, because here on the left we can coding the script. So here we can write the script and run it and save them after. Sorry, we can save them and reuse and recover and edit the code. But Python, as an interpreted language, permit or allow us to type things alive without saving the code. For example, I can tell tell it a equal t, 10, b equal 5, and I declare these two variables is an integer variable, and I can do the calculation directly without saving, without compiling, without these things. But in the first part of the course, or I could see the zero part of the course, we will start with a new file, a new script. So when we open the Spider, it will create a no title script, and on the automatically he created the first lines of the code. Let's comment about this code, these lines. The first line, we call shebang. This is the name of this. It is specialist for make the code portable from Linux to Windows to another operation systems. But without this, it will work on Windows, for example. But in Linux, it can be worked too, but it's strongly recommended left this here, because it will allow us to execute this code as a command on the Linux, because the script on Python can be used as a command. But without this, we can run this code without problem in Spider, because Spider call the Python as a command and execute the script. So this line is not necessary in this case, but is strongly recommended left here. The second line is for coding, for encoding. So the default options is UTF-8, but you can change here for your language and use ISO or ISO or another kind of coding, following this syntax. Hashtag, space not necessary, but hashtag, hyphen, this star, hyphen again, and this is the same after and inside the coding. The shebang is should be used with a hashtag and exclamation point. These two lines, you can see that the comment in Python is the hashtag too, but so it will run silently here. Another way to comment lines in Python is using a docstring. Docstring is this three quotes. We can use the double quotes or the simple quotes. 1, 2, 3, 1, 2, 3, and all I write inside this docstring will allow us to drop lines and other things without doing it for each line. Make hashtag each line, so it make our documentation of the code more easier. So this is the docstring, but the docstring can be a variable too, as I can show you after. So let's save the code first. If you press F5 in Spider, it will automatically save the code and run this code here. So if I press F5, he's asking me for save this in some place. I will save here. Script 0, for example, and it was saved. I run it, and nothing happened here, just a message for me. So I can print using print function. We can print the classical hello. Okay, hello was printed here, but now running this, I do not need to. No, let me think. Okay, let's go. So I think that the questions are being made on chat, and maybe.
I think Andre has been answering them. Lucas, go ahead.
Okay, thanks. Because I'm not seeing the chat here, so let's go. Let's start with some variables. I think the most simple variable is the string. So string is a combination of ASCII characters, and as ASCII it can be numbers, letters, symbols, and a lot of things. So let's create a variable 1, for example, and this for variable 1. Every string should be inside 2 quotes. It can be a simple quotes or double quotes, but let's create our variable here, Year of Water, for example, FLUXNET 2021. Okay, this is a variable 1, and I can print this variable 1 just for seeing here on the console, and it's okay. I can see Python. In Python, we call every variable have a type. In this case, the type of this variable is a string. But if you can confirm this, we can type here type of variable 1. So the class of this variable is a string. Okay. For example, if I create a variable 2 inside a quotes and write 25, for example, and print the type of variable 2, it is still a string because it's a number, but it's inside quotes, so it's not an integer and not a float variable. Okay, but I can transform my variable using the command int, the function int, transform this variable 2, which is a string, into a integer. And look that in Python, which we not need to declare the variables, I am transforming the variable 2, which is a string, into an integer without declaration, without without more complexity. And now it's an int variable. And with this int variable, I can do calculations and other things. With string variables, I cannot do. For example, if I try to sum the variable 2 with another number, for example, 30, it will return an error because it cannot make calculation of that. But if I sum 25 with 30, these two variables are string, it will be concatenated, not summed. So it will glue it or something like that. So it's important because we can manage a lot of variables, a lot of string variables with that. It's very, very useful on the future. You see on pandas. Okay, so this first variable 1 here, it have a length. Of course, a number, for example, like 25, or an integer or a float variable. Float is a real variable. These two variables has not a length. It have just the number itself. But a string variable has a length. The number of characters inside the quotes. So I can see, for example, the length of variable 1. 30 is the he counted every characters here, including the space. Space here is a character too. So it all this was counted here. So I can see, for example, the variable 1, position 1, for example. Watch. But so in Python, we call the position of string and a list and array, as we can see further, using the square brackets, not the rounded bracket, the parentheses. The parentheses is for functions and other things. For call the position, we use the square brackets. So the position 1 of variable 1, that is this string, is E. So we can see that Python started counting on 0, not 1. So the position 0 is Y. And the last position, we can do it using, for example, a try length of var 1. So the position 30, I will call the position 30 of variable 1 here, and let's see what happens. An error was appeared here because this variable has 30, has a length of 30, but the last position is not 30, is 29. So I should put here -1. So now I can see the Y and I can see 1 here. Okay, it's important thing because it can be a little different for another language. What else more? So, for example, I would like to extract these last 4 numbers for doing some calculation, for example. So let's create another variables, for example, year equal. How can I extract this? So this will be my variable 1, and I should count in the position. So I can count from 26 through len variable 1. Let's see what happened. 21. Okay, so 26 is this position, and 20 and variable 1 is the last. But it seems strange because the last position is 29, is not 30 like this. But in Python, the counting go on to the last position that you declare it. So if you want to see the position, a subpart of string, for example, and you have 10 positions, you have the from 7 to 10, you would like to declare 11 because the counting from Python ends one position before that position. So this is for the year, and I extracted this last position. But it can be a little bit annoying because I should count in every position before the 21. It's not good. So I can use this. Comment. I want the let's explain better. So the double points, it's separate when I start and when I end my counting. So if I put 0 through 4, for example, I pick year. If I put here 0 or maybe 4, I started in position 4, and it includes the space. The position 4 is the space, and I go to the end. If I put -4, I'm just picking the last 4 position of that string. It's another useful thing on Python because it made our life very, very easier. So this is to extract. This is still a string, so I should transform it into an integer or into a float to make some calculation. For example, now it's a float, a real number. Okay, so this is the main of this first part, and let's see another part. I will print some separation here, so I can print a string here just for separating and not do some confusion here. And if I'm going too fast, please, or too slow, please let me know, because I don't know what you expect. But let's see some things here. For example, for some reason, I would like to break this string into parts, and when I break this string, I will follow some rule. For example, I would like to break by spaces. So every spaces for me will a breaker here. So I can create a new variable. I will call variable 3. And this variable 3 will be a variable 1, and I will apply it into a variable 1, the function split. Split will split this variable following some rule. If I not declare any argument here, the default option is the space. So I'm breaking by spaces. Let's see what happened. Print variable 3, and here we have Year of Water hyphen, I don't know, in Portuguese is hyphen, FLUXNET-ECN 2001. So 2021. So this looked at a period, square brackets around this variable. This variable now have these square brackets. It means that that is a new type of variable. Let's see what type is. List. List, it's a really important variable in Python that we use to make a lot of calculation. And you can, it's a relative of an array, but it's not the same. Because with a list, I can accumulate a lot of information, but I cannot do calculation like an array. As you are, I don't know the word, when used to, in another language, an array, it's a primary variables. In Python, it's array not exist originally. We should call array from a NumPy, that is a package of Python, and I will talk about this later. So this list have some behavior similar to a string. In a string, I count every position for make the length of the string. For a list, the length is the positions too. So in this case, I have 1, 2, 3, 4, 5, 6, 7 separated by comma. So we have 7 positions, and we can call each of this position using the same rule we use it for a string. For example, the position 0 is year. The position 3 is this sign here, because 0, 1, 2, and 3. 4, 5, 6. So I can call this position 6, for example. It's not a number yet, it's a string, because I did not convert it into a string. A list can be filled by anything you can imagine. So we can put inside the list a number, integer or float. We can put inside the list a string. We can put another list inside the list. You can fill it with any kind of things. For example, using the command append. For example, I will append my name. I don't know. Sorry. I should take off this variable 3. Okay. Sorry. I should apply the function and refresh the variable, and now I have another position, and the append function put this new information at the end of the list. So if I do it again, now I have my name two times. I can put the variable 3 itself. So now I have, let's open here. This spider have an interesting function that you can click on the variable here and see the variable in a more convenient way. And the last position, look, I have the same, I have all the list inside this list as a last position. So if I call the last position of this list, for example, 9, 8, 4. What happened here? Sorry, let me.
Excuse me, could I ask a question at this point?
Yes, yes, of course.
Sorry, I'm an R user, so I'm questions about where this differs from R. I'm not used to the dot, like combining a variable name and a function name together to do a function. That's new to me.
Yes.
And then the fact that I just tried, you can't rename. So by adding Lucas on, I can't, using the var3 dot append, I can't rename that as var4. It just adds it to var3. But
yes, yes. This dot, this function with a dot at the end of the function did not we refresh automatically this function, the append function, do not need to refresh or recreate a new function. Just
so it's like recursive or something. It just adds on to the end.
Yes, yes. But for another kind of function, like we will see on pandas, for example, if I just do this dot function, some function, the function will not. The function will not refresh it. I will show you in the case when it's necessary to write here var3 equal var3 dot append to refresh the variable. But this function specifically do not need to refresh the variables.
And I suppose for a more general case, because the var1 dot split, you named that var3. So that was something that could go to some, that could be renamed.
Yeah,
there's a difference here between the dot split and the dot append. Where could I look that up so I would know which ones can be renamed or not? And
in this case, each case is specifically of each function. So you should see on the documentation of each function, because it's not a general rule. So
could you show me where in the? I mean, I don't know where the documentation is either, but could you show me what that looks like? The ones that can be renamed and reassigned, and ones that can't.
We lost your screen. You're not sharing your screen.
Oh yeah, I can't.
Right now. Can you reshare the screen, please?
I am not sharing screen.
No, we lost the screen.
Sorry, I lost. Okay.
Okay, thank you.
Okay, so Python documentation. Let's see.
I can't see you doing anything either. I don't know if it froze or something.
Oh, okay, I'm opening the page. So, for example, here's the Python 3.9 documentation, and for example, let's see the 3.8, for example, that which I'm using. So we have some tutorials here, but let me see here. For example, I have a lot of information here, a summary. So we can click, for example, string lists. So if you click in lists, for example, here's a lot of examples. So we can see, and you can know about, for example, append function here, or split functions and another functions. But each case have your case for kind of which you should or not should refresh the variable, because append function variable split function, for example, is a function applied to a string. So it will be made, but the variable one will not. Let's see what happened. For example, where is variable one? Sorry, variable one. Let's print. I did not print variable one. For example, here, my variable one is it's conserved as a split, as a string. I split it, but I not attributed this new function splitted, this new variable splitted to a named variable. So because in this case I should attribute this application of the function, but for list the functions used to list automatically refresh the variable without need to do a new name, for example. I don't know if I was clear. And then
this documentation, like I couldn't look up just the append behavior. Like I couldn't use this notebook or the spider to look up the dot append and like have it tell me that. Tell me whether it's a refreshed or not refreshed type of function. I would have to go to the documentation on the internet.
Yes. You should look to the documentation of Python. I will share the
I see here someone already shared it. Thank you.
Okay, but I will put in the chat. I think you can see. Sorry if I don't understand completely your question, but
Lucas, can I just add something quickly here? So the this notation, when you have the dot, this is basically applying a function to that variable. So when you have a variable, it will have a type, right? So in this case, you have a string or a list. And when you apply a function, you can think of that notation as passing that variable as the first parameter to that function. And that function can do what a normal function would do. So in some cases, it will return a value. In some cases, it will change the value of the parameter that you are passing. So it really depends on the function that you are applying. In this case, the append function is the behavior is inherited from lists. Even though when you apply that to a string, the behavior is the same, because Python is treating a string as a list of characters. So it is a very consistent type of behavior. So all the methods that you can apply to lists, you can also apply to strings, if that makes sense. Methods.
Yeah, and I suppose there's just a different, like, it makes sense. You have a variable that you're passing to a function, but that function doesn't stand alone. Like you couldn't rewrite, or I tried, I don't think you can rewrite that as append parentheses var3. Like it has to be in this var3 dot append format for it to work.
You could write that, but if you want to do that, you have to first import that function from the library. When you are applying that directly from the variable type, it's kind of a shortcut. So you don't have to import the append function and then apply it to that variable. If that makes sense.
Okay. Well, sorry, I've taken up enough of everybody's time on this. Thank you.
Okay. And it, like Gilberto say, it depends on the variable and the function. This is not the actual word for this is method. It's not function, because function we put the variable inside the function, but roughly is the same. So I can append something to a list, and I can do a same thing but not if I append, they automatically go to the end. But if I would like to inform the position where I would like to put some information, we not use the information, the method append, we use the method insert, but insert mandatorily needs two arguments. The information I would like to append, for example, Brazil, and on the first position, what position would like to put? So maybe position, I don't know, 5. So at 5 position, it will insert this. So Brazil was put here in position 5, and everybody after was moved. So it's again, here we have a list. So for a list, the methods just refresh this. So we should use this properly. We can't remove, so some information. Let me check. No. Sorry. We should informate here which we would like to remove. So I will remove my name. So now we can append, we can insert, we can remove, and do a lot of things with that. We can do it using a for statement. I will not cover this part now because the time is very short. I would like to focus on pandas, but if you would like to see more, I will present one example of for statement after, but for now we can append successively informations inside a list, use the append function inside a for statement, for example. So another, and just for finish this part, I would like to show variable 3. Let's see. Something about arrays. Arrays, for example, if I create a variable 4 now, it's a list. I will create this list. I can create a list, an empty list, and appending things inside it. Or I can pre-create a list, like, for example, this list made by numbers, for example. Okay. In this case, all this is integer numbers, so no problem for make calculations. But if I would like to operate, for example, this list with another list, for example, variable 5, that is, I don't know, 10, 5, 6, 50. If I would like to, for example, sum variable 4 with variable 5, we're supposed to 1 plus 11, 2 plus 25, but no. It will be like something like concatenating this, because list has not the power for do mathematical calculation. We can call some position and make a calculation in that position, but directly calculation we cannot do. For example, if I try to multiply, it will return an error because I can multiply two lists, and if I try, for example, double the first one, it will be double in the items, but not multiply each item by 2. So for this, I can change this position enter in a for statement, calling a position, for example, variable 0 and multiplying by 2. And this is okay because I'm now 1, that is variable for in position 0, multiplied by 2 is 2. Okay. And I can do it and replace this value, for example. I can do variable. I can do these positions. So now I change it. I can do it with other position. I can do it with this position. So I change the position. I call this position multiplied by 2 and attribute it to the position 0. So now, I refresh this. But if you have a enormous list, for example, from a data set, you to do this because it's very, very annoying. So we can using NumPy. So let's import NumPy. So now I am importing this package, and I will change the name as NP because I'm putting an alias for NumPy, for the name NumPy, just for make my life easier. So, for example, NumPy has a lot of mathematical, a lot of algebra functions, a lot of things like MATLAB, R, and another language. So one of the mathematical functions on NumPy is the array. And array, yes, is something like a list. It can be made into a 1D dimension, 2D dimension, and a lot of dimensions. And with 2 or more arrays, I can do the mathematical calculations easier. For example, I can transform a list into an array, for example, using this function np array. And now I am transforming using the function array. Each is inside the module NumPy, and I am transforming this list into an array. Now variable 4 is not more array. Now is a NumPy array. No, it's not more a list. It's a NumPy array. It was transformed. And with this array, if I, for example, I can make the same thing I did with list. For example, operate individual positions without problem. For example, here again is the same. But if I want, I can multiply all variable by 2. And now each position was multiplied by 2. So it's more easy because 1 makes 2, 4 makes 4, 2 makes 4, turns 4, 20, 40, and 60. And now it's a powerful of NumPy array. It's not a powerful of a list. So if I transform my variable 5 into array 2, and in this case, I need to attribute this to a function, I can, for example, multiply variable 4 and variable 5, and the result is one multiply by 10, 2 by 25, and go on. So, and I can sum and do a lot of another mathematical calculations like mean, like standard deviation, and a lot of things using NumPy. Using lists, we cannot do it. We can calculate inner product. We can calculate a lot of things. I can, for example, attribute a 2D, like a matrix variable, and multiply and using this. So this is just a fast introduction to Python, just for remember or for formalize some kind of in principle, some kinds of variables, types of variables, because these type variables can confuse us sometimes, and on the pandas we will see that it's important to know which kind of variable we are working. So, for example, if I would like to create a variable 6 that will be a matrix, for example, I can create a list of lists. That is, each position of my list will be another list, and this will be transformed into a matrix using the function array. For example, 1, 2, 3 is the first line of my matrix. I would like to close this because I am create a list of lists. So each position of my list will be another list. So the position 0 is this list, the position 4, 6, 7, and 7, 4, 6, 6, and print variable 6. Now it is for me, it's a 2D array, it's a matrix, and you can use specific functions of algebra. You can include it, make some calculations with the matrix, or determinant, product by product inter to matrix, and what else. So this is our first part of the explanations. If you have another question, please, we can tell. Now, because the next part, I'm going to introduce some function of pandas. And with pandas, we can use the FLUXNet dataset itself, as promised, and we will use these informations. So let me see. I think everything's okay. Okay, let's go. Now, if you are using the Spider, we can create a new script, Control N, or here probably Control N. Okay, and let's save. This will be our script 1. The script 1 now will use pandas. So we must import pandas like we imported NumPy. So we will import pandas as PD. Again, pandas is a package. So in this package, we have a lot of functions which we use here. So with these packages, you should call using the methods on pandas. So PD is alias, and it allows us to make it more easier. So let's focus in using PD. You can use another name. You can use the name you prefer, but in general, all tutorials, all information on internet use PD. So if you would like to import some code or use another code, or it can be easier. So let's use this name, but you can use any name you'd like. The main structure of pandas is made by an entity or a variable called data frame. A data frame is something like a table or something like a spreadsheet. So a data frame contains a lot of informations inside, and each information is separated by rows. Each row is identified by an index, and each column is identified by a key on the header. So we will present this variable. I will present a variable easier pandas data frame, because we can create our data frame from zero manually, or I can read some file like FLUXNet data and transform it in the data frame and make our operations. So for example, let's create data frame 1. Again, it's just a name. You can use the name you would like. Let's create a data frame 1. So we should use the PD, because PD is the name of pandas, the package, and I will call some function inside pandas. We have an infinity of functions, so we should use this point to call this the method for PD. And data frame is called by this name. This data frame, it's a function, it's a method of pandas. So you must respect the form of writing. Python is case sensitive, so the upper or lowercase is important. So in this case, data frame, the first letter is uppercase. So data frame, if I just do that and print df1, what? Oh, sorry, I forgot the F is it's uppercase too. So if I print here, we will see that's an empty data frame which have no columns, which have no index. So it's not interesting for now. Let's, for example, use this variable 6 in another script and put here I will transform this matrix. I can do it. I can transform this matrix into a data frame, for example. So variable 6 will be automatically converted into a data frame. So it's very, very useful when you have, for example, a numerical modeling divided into a grid. For example, we have a lot of grids and points and number at each point, and to have, for example, on the vertical, we have the timestamp, for example, and the horizontal, the X direction, for example, or we have X and Y direction, I don't know. But if you will convert your matrix calculated in your module, for example, we can transform it into a data frame just putting this matrix inside the math data frame. And it's very, very useful, especially when we would like to calculate the things which we will do. And when we would like to output this file or create an output file, because it's more easy to write an output file in pandas instead using the pure Python, for example. So this is our data frame. I can see, for example, how is the index of this data frame. So the index of this data frame automatically was created as 0, 1, and 2, because I'm not informed inside here what is the index. The same for the columns. Just 0, 1, 2. But I can change my columns, for example. I can, for example, I can define, and in this case, which I promised for the last question. Now, in this case, I should refresh my variable in pandas. We should refresh the variables, even applying a method. So df1 will be a df1 columns. So I will change the columns. Will be, for example, I can create a list of positions or names, for example. So column 1, column 2, column 3. So if I print df1, now I create, I change the column's name, so the header now is that. And it's very useful because I can call some position, some columns of the data frame using not the position, not the number of position, but the column. So 147, I'm calling this. And it always indicates the index together. For example, C2. C2 have the columns 2, 5, 8, and the index 0, 1, 2. Again, it follows the Python default, starting 0. But I can change. I can change the index, for example. As for example, I can create a list, for example, 10, 20, and 30. So now this is the index of the data frame. And I can also change, I can create not just number index. I can use, for example, another kind of things, A, B, and C. This is a list of strings, and now the data frame has this header and this index. So I create my own data frame manually. I can create in another ways. I will show you if you have more time at the end, but I will focus on the next step on the data from AmeriFlux. So because I think it can be more productive, but let me organize this. So I create a lot of things. I can make operations like removing some lines, or line or row. I can put in another row. I can do anything, and I'm not restricted with working just with numbers. So I can put a new row, for example, and each position can be strings, for example. I'm not restricted. with numbers. So let's see the next part of this. So I have a script that I save it here for show you. So at the end, or I will send it for Andre, and will share with you these codes, so you can use these codes after this presentation. So let's create a new file. So FLUXNet script. I will import this for now. Let's see what happened. A way to create automatically data frame, it's to read a file. So when we read a file, we can create auto. If I read this file here, it will pick all this information, put in the data frame, and I can work with columns and headers. I will do something a little different for now, just because this data set, it's a very, it's too big. So for example, my file 1, because you will see, because I will call in this. So my file 1 will be a data frame from this data set here. So look that we have a lot of columns. It's a really, really big data frame. We have a lot of rows, so it's a little bit heavy to run the file every time. So I will run this one or twice, one time or twice, and after I will work directly on the console, because it's more productive. I don't need to every time read the file, read the file, and it make the work a little bit slow. So let's use the function, the main function to read file. The function is PD. PD is pandas, and from pandas I will use the command read CSV. Okay. CSV is a comma separated value file, but it's not restricted to CSV. For example, this file could be separated by spaces, by tabulation, by semicolon, or a dollar, no, not useful, but the commercial E used on LaTeX, for example. And we can use every ASCII file, any ASCII file, and the extension doesn't matter. So even the function called read CSV, I can read dot, for example. I can read dot txt, for example. I can read anything made by ASCII files. For example, exist other functions which we will not see here for read a spreadsheet on Excel or LibOffice, for example. We can read SQL file and other kind of files, but we'll focus on FLUXNet data, which is made by ASCII file. So here we will write the name of the file. So let's do it. Let me copy this for not need to type manually. So I put here the name inside the quotes. Again, it can be double quotes or simple quotes. Point CSV is the name of this file. Again, this doesn't matter. If you have another extension, not problem, but you must to inform the extension. And if you just do that, the reading from read CSV will separated every columns by the comma, because CSV for default is separated by comma. But if you have another kind of separation, you must inform for him. So for example, if this file was separated by space, we put here space. If semicolon, you put here semicolon and whatever, and go on. So in this case, I do not need to inform, because I can be redundant and put here comma 2, no problem. So when I do this, I will print fill 1. I forgot to put the file here. Okay, now is this. Of course, it should be in the same directory, and I forgot to put in my directory. So here, he is thinking, and now it presented for us the data frame. The data frame in this starting step is a mess, because he just the pandas, no? Okay, pandas just located the comma, separated all columns, and okay. But I not inform the index, for example. He not know what is the index. So the index for default is the counting of the line, starting on 0. And the header by default is the first line. So the first line, which contains the header, will be the keys of each column. So each column have a key, and automatically he knows which is, for example, if I print, for example, this variable here. So now he's running. And now he presented for me this last column here, because I asked it, and I did not anymore counting every column of the file. It's annoying too, because this data set contains a lot of headers. So imagine you should counting 0, 1, 2, 3, 4, 5, 6. Okay, now this my data is in this position, and you can confuse and you can change accidentally the column. So on pandas, it's not a problem more. So you can just inform the header. Okay, let's see what more. For example, if I should inform what is in the index, because of course I'm not interested to use the line counting as an index. I would like to use, for example, the timestamp start, or timestamp end, for example. So I can inform him the index call equal, and I can put here the time start as a index, and if I print, I will print again this column, for example. Now it's running. He present as an index this column. So
Could you
all
show us
data-
your code there, please? Sorry, it's hidden on the in the
Sorry?
scroll. We can't see what you just typed.
You are not seeing?
Sorry, could you scroll to the right?
Okay, sorry. Let me. In Python, I can break the line without problem, so I will do this.
Lucas, sorry. There are some people asking if we will have a break. They are asking here in the chat.
Okay, which you think about more, I don't know, 20 minutes and start and break and return? Organizers.
I think it's okay. Fine.
Okay. Yes, I think a break is good for a coffee. And let's continue through more minutes just for now. Please, Andre, advise me when we are around 12, I don't know, in Brazil time is 40 and 10 minutes.
You want to stop at 2 o'clock p.m. here in Brazil?
Yes, please.
Mark 10 minutes. Okay.
Okay, thanks. So I think now the typing is appearing. So I can use the name of the column as an index, but I can use the position too. So the position 0 of this data frame, timestamp start, is a position. So the same things will happen. So now I created this data frame using this. Look, something happened here. The first one is that this for pandas is not a timestamp yet. It's not a data type. For him, it's a number. It's an integer number. So it's including a big number. So I should not use this like a timestamp. We must convert. We must inform him which is the format, because we have the four first characters is year, after month, after day, and hour and minutes. So we must inform. If the format is in the ISO format, for example, something like that. For example, if the data on the column is in this format, for he is okay. You will automatically convert it into a timestamp. But in this case, not. So you must inform him this. I do it after. Another thing is, look that minus 9999. It's not a gap properly. It's an integer number. It's minus 999. So it's not a number. It's a number. So it's not a missing data for him yet. Some missing data exists. Some default missing data. For example, a not filled space. For example, if you have a comma and another comma, and inside these two commas is an empty space, this empty space will be automatically converted into not a number or a missing data. If you have NA and some variants of NA, NAN, NAT, and another kind of this, it will be automatically converted into a missing data. But if you would like to inform him which is the and how should be intended the and the missing data, we should use the function NA values equal minus 9999. So now when I rerun this code, all this data, it's automatically another number, and it will be it will allow us to make a lot of calculations, interpolation, filling process, and another kind of things. So let's do something here. I will inform to the pandas. We already know that the first column is the index, but it's not a timestamp yet. So I will convert the FIL1 font index to, let me just, pandas has, of course, your own documentation too. So if you Google PD font, for example, or just read CSV, for example, in the documentation of pandas will appear a lot of options for this. Of course, I will not cover all this, but we have a lot of possibilities here to our data. Something like, for example, if your data are separated by space and the decimal is a comma, not point, for example, you can declare it. We have a lot of possibility here, explanations here, and some examples at the end, or here not at the end, but in the tutorials, like this, for example. This tutorial is very, very good. I will show you, you put in the code that they will send to you. I will put this as a comment on the code, and you can consult it here in the future. So we have a lot of options here for read CSV. It's a really powerful function. So here I will declare something. So I will use pandas, and I will use the function toDateTime. Sometimes Spider automatically form here for us. So here is the toDateTime, and I will convert this index, which is these numbers, into a date time. Oh, sorry. So I'm converting the FIL1 index, the index of the data from FIL1, into a date time. If I just do that, let's see what happens. It will do something very, very strange. Look at that. Then this year have not is not this year. Is 70 years. Okay, so it happened because it is a integer number. And for pandas, the integer numbers means nanoseconds starting in this data. So it's not, for him, it's not a format, a default format for dataset, for date time. So we should inform him the format, and the format equal, and so we should inform. The Y uppercase is for it's year with for characters. Again, we have month. After we have day. After we have hour. And after we have month. So if this data was separated by a bar or hyphen, for example, you should inform him. for example, if you have space here, for example, but it's not the case here. In this case, all this data was glued. So we should inform this format for him. Okay. So now when it tried to convert now, this is what we expected. And of course, it was done just one index column, not in the timestamp end column, for example. Okay. I will show you. I will show you, for example, if I would like to exclude, for example, this column now. This column is not important for me for this situation specifically. I would just want to keep the index and other variables. So I will drop. Okay, so I must refresh my data frame, dropping using the function drop, and this function will drop something. What I would like to drop, for example, I can drop this, so I can inform him what I'd like to go to the trash. And if I just do in this way, by default, the drop function will try to find this information on the index. So I must inform him that the axis is 1. 1 means columns, zeros, which is default, means rows. So if I put, or I can write column, or I can write index. I prefer the numbers, so I will inform search for timestamp end on the header and exclude this column. And now my new data frame has not anymore this information. If I did not refresh my data frame, this function will be applied, but my data frame will keep the same. So I must to attribute this operation to a new variable. I can create a new variable and preserve the original and the new one. But in this case, I would not like to preserve the old one. So let's keep it. Okay, let's. I think now it's a good time for a break. And I don't know. What do you think? And we can continue later. André, Gilberto, I don't know.
Yes, at 2 o'clock now.
Okay.
How long?
I don't know. Well, what do you think?
What about like yesterday, like 10 minutes break?
Okay, for me it's good. 10 minutes,
Okay,
so return 10 minutes.
So in Pacific time, I think it's gonna be 10:14, right? Okay. See you in 10 minutes.
Good.
See you.
Doing great so far. Keeping up. So thanks again.
So I hope everyone was able to have a small break. Can we keep going forward, Lucas and Andre?
Okay, I'm here. I think I can continue. Let share screen again.
Lucas, if you can help Dilara, he's in the chat with a problem with the data frame. But as Gilberto said, I think she downloaded that version of the file that has some site informations in the two first lines. So you can have a command to skip the first lines, but you can also just delete those, but you cannot delete the header.
Okay, I was reading some questions, and this is always happens. It's not. It often happens, and for example, I do not. The words tell you to manually remove some lines because some files is too big, so it's not and if you are working with a lot of files, it's not so productive. So for example, if you have, I don't know, information here and FLUXNet and blah blah blah, so we have now, for example, 3 lines, 3 extra lines here. So we can use the function in the here that skip rows equal and the number of the rows you would like to skip. So if you have three lines you would like to skip, we skip these 3 first lines and start on the 4th line. So it's important because a lot of data set contains this kind of information before the header. So you can use this function for this situation. So another thing here is that if you skip a row that contains the header, for example, or if not contains some header, just the file start something like that, pandas will try to make this as a key. The first line always is the key from the data frame. So you should inform him what is the column using some specific information after reading. So you read information and tell him what should the name of the header, the keys of the header. So in this case, we should use the header. For example, you should write, if your file do not contain any header, for example, we should informate him that header equal none, because if you do not do it, pandas will try to use the first line as a key and as a header. So you must inform that we have no header, and we should inform him file1 columns equal, and you can put a list of variables name here for him. So this is another situation that can happen. Following, in general, we are not interested in whole data set. Whole data sets is too big. It's not, each of us are working in a specific research problem that not use all the variables. So we can select a subset of the set. So I can, for example, redo my variable or create a new variable, which will, for example, a subset of my set, so, or of my data frame. So I should use the square brackets to select values, and another inside double bracket here to select what columns I would like to work. For example, I would like to work with TA era is one of the columns of this data set. But I don't know what is the columns. Okay, let's print the fill1 on columns just to check what is the columns. So here appear a lot of, we have 2016, 16 columns. It's a lot. So I will select one of them. So T-era is one of them. Another would like to select, for example, RH, relative humidity, LAF, MDS. I previously selected this, and PF, precipitation. So I have four, double S window speed, and I know that this variable is inside this my data frame, and I could see, as I told, looking to here. So now my fill is my new fill, which was refreshed. It's just a subset of that set, and that set not exist anymore. If I would like to maintain, I would like to write another variable. Okay, and in this case I will conserve my old variable. Now look that I have data starting 2002 through 2011. I have some data, I have some gaps. WS apparently have just missing data, but not because it break it for not present all data because it's too big. But I can see, for example, the first 5 lines of this data set using the command head for by default use print the 5 first rows, but I can see, for example, the first rows, but in 13 here. So now I can see all my data here, and it is varying along the time. So I can select to a specific date time. For example, my study is not from 2002, from 2011. I would like to see just the year 2006, 2004, 2006, and 2004, 5, and 6, for example. So again, we will refresh our data set. And here I will put the starting timestamp and the end timestamp using the new format presented here. So 2005 0101 space 000 through 2006. Right. 4 was I pronouncing? 1231, for example, 130000. Now, this is my new file. Again, I refresh it, but I could keep it. And this is my data set and the 31st lines. Now, I will read, I will make the same read for the SA3 station. But I will previously do something different just for show you another way to do it. So instead use index column equals 0, I use the name of index column, start. Again, NA values is the same. I will change the name of the file now. Okay, the name is roughly different. Let me see. Here. And I can inform, in order to use a subset, I can inform inside here which columns I would like to use. So I can use the command use calls, and here I can put the same columns I would like to use here. Why the same columns? Because I would like to compare variables in these two stations. But of course, I would like to create a variable with a different name. Time start. In this case, when I use the function use calls, I will organize here for you. Okay, nice. So now I am using the same columns, and I am doing something similar. In the same way, I need to about the format of the data. I do not need to drop, for example, the timestamp end, because I not selected previously. I just selected this. So now I will not read all the file. I will just read the files, the columns which I selected. So now I can print, for example, let's see, FLUXNET had and FLUXNET had. And let's compare something. So we have the same. Where is my data set here? I print one, sorry. Let's print less just for make it easier to see. Let's look something. Uh, 13 and 2. No. Fine. Look, that is more slowly because I'm reading two data sets. Look that. I have two data frames. This first data frame is starting in 2004 because I selected. This second data frame, I not define when, what the time I would like to work. So it starts in the start of the file. We have some the columns, which is similar, so TL era, but the sequence is different. Why it happens? Because when I do this kind of subset, the pandas will put the order of the columns in the same order of I informed here. But here, he's just selecting these columns, but it will preserve the same order that was in the original file. So in this case, it will be in this situation. But it's not a problem. Why it's not a problem? Because when I would like to see some operation using, for example, this as a key and this as a key of this data frame, it will call the specific column and not, and he can locate it very, very easy. It can, sorry. So let's go. Now we have two data frames, and I can, for example, put these two data frames together in just one data frame that we will make some operations, for example, and put into a outside file, for example. But let's do some basic operation here, for example. Let's do fill3 plus fill1. Just it. I will not attribute into a variable. I will just do the calculation. Look at that. Pandas, what they do? What it did. He summed each the columns, which was the same, and when was in the same timestamp, it summed, but it was summed. But if if the data was not the same, he's incapable to do this calculation because it's not a number. For example, the fill3 data set, I started in 2000, and I don't know when it ends, but it's not important now. It started in 2000, and this data set fill1 started in 2004 because I defined this. So it will just sum the same data set in the same row of it. One way to see that is writing into a file, outside file, and see what happens. Let's define this to fill out, for example, will be this sum, and I will write this using the function toCSV. Okay, toCSV, it's a way to write our calculations. In this case, I will pick this data frame, apply to function or method toCSV, and it will write this. So out file1, and I can use any kind of extension. I do not use, I not should use, for example, CSV. I can use TXT, DAT, or what else? Float. I can define, for example, the format. I don't need to define, but I can if I want. For example, I would like to preserve 4 decimal places. So when I run this, it's going to be run. Let's open the file to see my alt file 1 here. When this data set was not in the same time, any calculation was done. But when they have the same date, the same period, the calculation was done. In this case, I summed some variables. And look that the SA3 data set is a half-hourly data set, and the SA1 is an hourly data set. So this will occur because one of them do not have the data in this timestamp and another have, but I will not, the program will not be the calculation because it's not make sense. So this calculation was respect the timestamp and respect the name of the columns doing the calculations column by column. So it's more easy to work without counting and doing that. So another things we can do, for example, is putting these all files together. For example, let's see, let's create one file that have the first 5 columns is the data set from file 1, and another 5 columns will be the data set of file 3. So I can do it concatenating using the function pd.concat and informing the data frames I would like to concatenate, so that is put together. But we must use something like a list to do it. And again, this concat function by default do it in row order. So it will pick the df3 data set and the FU3 data set and put below the first one. But if I inform axis equal 1, which means columns, I will put this in 2 columns, in 2 separated by columns. But I would like to inform a new variable now. So fill merge it, for example. It's a name, it's not a function. And I will write it into a 2 CSV for better visualization. Let's see what happens. The name will be alt file 2 for not overwriting. Let's see the overwrite 2 is here. Look at that. But now we have a problem here. In the first, he put everybody together. So the data frame from the first station start now in 2004 and start here 2004 and end 2006. The data set, the older data set, start in 2000 and have half-hourly data. So in this new data frame that is a merge has not data from the first data set, what was put first in the merged function, and the others what was put in here. In 2004, no problem, we have, but one file exists half-hourly and another do not exist. So we can, for example, make these 2 data frames now made together. We can made it have the same period, for example, because I'm not interested in days before 2004, for example. So I will do few merge. I will rewrite my file using a function that the name is reindex. I'm redoing the index of this whole file that contains all this data. So I will use which rule I can use. I can use the fill-tree index, but the answer will be the same, or I can use the fill-1 index. So I'm redoing the index of this new data frame just for this period here. So when I run it, I will obtain this new file that are being updated. So now I have just hourly data starting 2004 and ending in 2006. But here, look that I have the same names: TI-era, RH. It's a problem because it can create some confusions for pandas. So we should put manually or using some operation to put the right name of each columns. So now is the moment, is the time when I will teaching how working on for a statement, for example, because I can rename some columns or all columns of a data set, for example. For example, fill-1 have these columns names. I can, for example, rename using this function, rename, and this function must use another type on Python that calls dictionary. It's inside this rounded brackets. So I will inform him two things I would like to change: the currently name, and the new name. For example, TI-era and TI-era, and I will put underline 1 to indicate that I'm talking about the first station. So when I rerun this, it will be updated here, that would happen. And now was updated. No. Why not? What happened here? Okay, I forgot to tell you something. The most kind of variables on pandas in general, the default options is by rows. So it will search this information on the row, on the index name, but it's not exist. So I must inform this is access equal 1. And now it will be run. And now we can see here the TI-era was changed. The other columns not, but the TI-era was. But I will not do it manually for all these variables. So I would like to do, I will use a for statement. So I will for I create a name, for example, call. I create this variable in few point columns. Few one. In this case, I will walk in and searching every positions on columns. And here I will change something. I will do an operation using a string, you know? So I will do this. I will do the same operation, but instead use here the TI arrow, I will use the call. So I'm calling each position. I'm walking through these positions, looking for this and concatenating this to one. I will do it for column one, for the first one, data set, and I will do it for the second one, the file tree, the same. But for the file tree, I would like to see this name. So I will put this here. Of course, before merging process, and now my new data frame has the columns correctly identified without confusion on the name, and I can do correct informations.
Sorry, Lucas, I will interrupt just for a second. So we're planning to end the workshop today at 12 p.m. Pacific time. So we still have around 1 hour and 15 minutes. So yeah, so not to make confusion, yesterday we ended in it was 3 hours, so today it's gonna be 4 hours. Yeah, thank you, and sorry for the interruption, Lucas.
No, sorry, I don't understand completely. I have 1 hour and 12 minutes. Yes.
Yes, 1 hour and yes. Correct. Is that okay?
For me, it's okay, but you must remember that we have the matplotlib. I don't know if you would like how you work with that, because in this case I have just 12 minutes. So how can we work with that? What is the process? I don't know about Andra.
If you want, Lucas, you can. I think you can go with the Python course to the end, and we can send the Raphael video to the audience.
Okay, I think it's more an option for the audience than me. So I don't know what the people would like to see.
If the audience could respond in the chat, what do you prefer? Because the matplotlib instructor will not be here today, but he recorded a 1 hour video. But we can use this 1 hour with Lucas going on pandas, and we can give a link for you to download the Raphael record. So if you could please say in the chat what is the preference.
So Lucas, you're winning.
So okay, I will continue and waiting for the response in 12 minutes, 11 minutes now.
Okay.
Okay, thanks. So how? Okay, we worked with some data frame operations, but now let's go to another things more interesting. So let's see what more I prepared here. Okay, we are writing this. Now let's work with gaps. The most people concerned about gaps. For example, here we have gaps in some variables. Okay, and these gaps is not in the original file. The gaps is a -9999, but when I converted this into a not a number or NA values, the output of these files will automatically is an empty space between the separation. Inclusive, let's see, white spider here. Inclusive, I can put here more options on my writing. For example, I can put here the separation, sep equal, for example, my separation was a comma, but I can put, for example, a semicolon, for example, semicolon. I can put, for example, another decimal for another language, for example, not dot, but for example, a comma, for example. So you can use this information, you can put this information to as CSV for writing your code. Let's see. So yeah, we can also inform him about the NEA values. So put here. So I can inform him NEA rep and inform another number, for example, again, -999, for example, or another number. I don't know, something like that. So it will run, and the new file here, now this place have separation by comma, semicolon as separated values, and the gaps now is NAN. But I strongly recommend do not use this information, this option for to CSV if you intend to use this generated file into another pandas program, because automatically will be read as a gap. So it's more interesting, keep it empty. So another things we can do here is, for example, let's investigate how many gaps or how many gaps we have in this file, for example. So, for example, each variable has your own gap. So in another language, I should make a for statement or a do statement, and for each variable counting if and make a if statement and look if it's not a number or it's another number, and create a variable to counting this variable. But here we can do this very, very easily. So I can print, for example, I can see using the function calling isNA. IsNA will search inside a data frame and look for not a number value. If it is not a number, it will return a true. If it's a valid number, it will return a false. So I would like to do this on my field merged is not a number, and for example, I will put this information on my variable called fill gaps, for example. Okay, so let's print this fill gaps to see what's happening. This data frame generated here it's a collection of true or false, true or false. When it's true, it means that is a gap or a missing data. And it was false, it means that is a valid number. But I'm not interested in false or true. I'm interested in the amount of gaps. So let's sum these quantities. So it's running. When it runs, we have it returns some kind of summary of each column and the amount of gaps. So here, 0 gaps, 0 gaps, 0 gaps, 10,000 gaps, 70,000, and go on. So this is the gap, the number of the gaps of each column presented here as a data series. I forgot to present this another variable of data, pandas. Pandas have the data frame, and each column we call as a series. So it transformed this information into a series, and the index of this series is the name of the variables, and this is the quantities. And I can do, for example, I can do it in some kind of percentage, for example. So I can divide it by the length of field merged and multiply by 100. And now I have the percentage of each variable, it's calculation, of each variable that contain gaps. Okay. So now,
excuse me, Lucas, could you break down the syntax for that line 38? That's pretty novel to me. We've got parentheses, dot, sum, parentheses.
Okay, here.
Yeah, it's pretty, that's new to me.
You would like to explain again, or I don't know.
Well, you have a variable dot is NA, a function, and then you can add directly another function or method on top of that.
Yes, I can do it. I can create, for example, I can do this step. I have until here, I have just true or false. When I apply the function sum, now automatically the pandas will sum every in this case, every true variables, and he present me the sum of true values of each of this column, for example. And I can do it inline without necessarily refreshing my variables, for example. I could do it like this, but but I can do it inline without not problem. If you are not very comfortable with that, do it line by line. But when you are making more confident, we can do it in sequencing.
And then why is there, okay, so that makes sense. You're kind of chaining those together with the dots
Yes.
or with the periods.
Yes.
So why is it len fill merged and not fill merged dot len?
No,
the part that you've commented out.
Okay. Len's a function, not a method. Method is that things that you put on the end of and apply this method into a variable, for example. The len is a function that return to me the length of this variable. In this case, I'm seeing the length of the data frame field merged. So the length for default works in this way, not without dot. In this case, this is the way that he worked.
Okay.
Lucas, can I jump in real quick here? So len is a function that's a standard function from the Python library, and you can apply that to any array. There is a function or a method that is part of the data frame that is called size. So you could use fill merged dot size, and you would get the same effect. But a lot of people use len because it's a function that will work across many different data types. So it's kind of common to use that. But if you want to be more precise, you can use the attribute size for the data frame.
Yes,
Okay.
yes.
And so the difference is size is in the pandas or something package, and so it's a method, and length is a base Python and is a function.
Yes, that's right.
Yes. And size will return not just the length, but the something like a matrix. So the number of the rows and the number of the columns too. So the sizes return another variable, not just the length.
Okay. And I think that was the other thing, is like, so you would have to know, because you had experimented enough with these functions, that these are applied columns. This is like column sum. This is not just summing the whole data frame or summing by rows. It knows to sum by column, and length, it also knows to do the length.
The length of the rows, yes.
Okay. And is that one number or multiple numbers? Like, I guess I should just test that.
Sorry?
Like len merged, is that just returns one number. So you can divide a vector by a single number. Or I guess you guys don't, it's not a vector, it's a something else.
Yes,
but.
and the data frames works like an array, as I shown previously, and we can operate whole data frame to a number, to a one number, for example, multiplying this whole data to a number, for example, or dividing in this case, or in this case I am including divide and multiplying
by a single number.
By a single number. So it's interesting that we have, for example, when I summoned here I summoned column by column, which has the same name. Mm-hmm. If they have the same name, it will be summoned. So this will be done in this case. I don't know if I was totally clear, but
so that was that. So up there in line 31, that was more like an append or something. Like you're appending new columns to the existing data frame.
31, sorry.
That's more like, is that an append? Is that kind of like append, or like you're adding new? I shouldn't say append. Like I don't know how the function actually works, but it's adding the columns.
No. In 31 column, I'm summing columns that have the same name. So in this case, I changed the name. So this is
so it doesn't work anymore. Okay.
Yes.
But now, but before it was actually adding the RHs together.
Yes.
Even though it doesn't make sense to add RH together, but that's what it was doing.
Yes. Yeah, I should.
Okay, column-wise addition. I didn't catch that earlier. Thank you.
Yes, a concat is something like append, because I'm appending in this case by columns, or I can append on row by row. If I change here for 0, I do it by row, and for 1, I'm doing by columns. So in this case, I am appending this fill1 with fill2 and putting these two side by side.
Okay, and if it was 0, it'd be top and bottom.
Yes, 0 indicates I'm doing by index, and 1 indicating I'm doing it by columns.
Okay, thank you. So there's just some cases where you have to specify that, and then there's other cases like with the dot.
Yes,
where it just is automatic. It knows which way you want to do it.
Yes, in general, dot is a method when we are calling from a package or some specific operation for a specific kind of variable. And some functions in Python will have some arguments, and one of these arguments can be this variable. So
The axis.
no, it's not a closed rule. In this case.
Thank you so much.
Okay. You're welcome. So here we have this, we investigated the number of the gaps in this case. And now, for example, we would like to, for example, fill these gaps. So how can we fill these gaps? Let me just print this, not this, but the merged when I would like to know if you are continue here, or I don't know about the chat. I did see it.
Yeah, you're continuing up to the end. I think that's what the chat says.
Okay, nice, thank you. So, for example, I will print again few merge because I would like to see where are my gaps. Just for example, makes sense for you. So let's see what we'll print here. So nice. We have in the beginning we have the gaps. So let's print some, I don't know, 13 lines. The first 13 lines. For example, we know that double S, the wind speed, have a lot of gaps here. Okay, what will you do? So for fill this gap. So I would like to fill the gaps in this variable, for example, double S underline 3. So I will use the function. For example, I can fill these gaps using a rule, such a rule I would like. For example, it's not make sense, but for example, if I would like to put here the temperature, I can do it. Or I can interpolate this data following some rules, for example, and it's a lot of possibilities. So let's first of all, let's create a new column. I did not teach in that. Let's create a new column for the fill merged. This new column we'll call, for example, double S3 fillet. So I will fill this gap. I created this new column, and to create this new column, I must attribute a number. I can attribute the number 5, for example. So all the lines of this new column that I created will be the value 5. But it's dangerous. Don't do that. Let's do, for example, not a number value. It's more security because it will be empty. So let's see what happened. My fill must stay here because we're not working with that. So I create a new column and I fillet this column firstly by default it will to the end of the data frame, and now it will always, this data is empty because I put not a number value. NP comes through NumPy. We can fill this. So to fill this, I must use the function lock, and this I'm informating him that I'm changing all lines. Here is the line, so I'm changing all lines, and the key of this of our data frame, I will fill this column with some value. For example, in this case, the own value of WS3, for example. If I do it, I'm just copying this values. It's not too too much interesting, but I can use the function interpolate, for example. If I just do that, the general rule for that is the linear interpolation, and it will ignore if have gaps in the beginning, and will start interpolation from the next line with a value. So this first line is always not a number. And let's see what happened here. WS3 start being filled from here. So this is the value, valid. And let's see when we have here, for example, here we have not data set. Okay, let's do it better. This is not good. Let's print a subset, okay? If you merge it, I would like just to see this too. So I'm printing a subset. I'm not doing changing. I'm just printing a subset of this data. And this data just for compare. And I would like, I don't know, the 51st rows. Always is not a number yet. Let's see more. I don't know when the valid data is beginning. I don't know. Let's see. Let's search. I don't know. Let me just locate when this beginning, just for comparing. Sorry. Let's change the time stamp here just for see better. I selected a time when it was. I'm just changing the data, the time here, because I know when previously when we have maybe some data with filled and not filled data here. Nice. That's okay. Here, I changed the date, the range of data, because I knew it that this data contains WS3 contains here not a number data, it's a missing data, and here the data was filled following the rule of the linear interpolation. So it was done by it. In the beginning, look, we have a not data here, and it will not complete this value. To do that, we must inform him that I would like to do that, informating the limit direction, for example. In this case, I can put back, so the initial values will be filled. I can put forward, and so the end file will be filled too, or I can put both. So all data will be interpolated from beginning to the end of the file. Here, the interpolate function or method on Pandas has a lot of options, and you should choose the best one for you and for your work. So we can use, for example, not just the limit direction, but the method linear pad that fill the values, copying the values from one point to another, existing some spline and another kind of interpolation. So you should use the documentation to see that, and it will preserve our data set. For example, recover some point of missing data. But for example, if I would not like to interpolate or make some calculation with the whole data set. For example, for some kind of motivation, I would like to fill the gaps at night, for example, just for daytime, for example. I can do it using some rules, for example. So I can use the function. I will create, again, a new line, for example, in order to preserve this field. So, for example, day. And I will create a new column on my file, my data frame. This data frame initially is totally filled by not a number. And what I will do the following. I will use this function inside here. I can do a true or false, a conditional operation. We not need to do a for statement, and this for statement made if is or if or make these things. We can do this inside this square bracket here. So what I can do, I will follow the following rule. If the index of this data frame in hour is bigger than 6, for example. Let me reduce it. Bigger than 6 hours. I will recover the value of this variable here. So I will explain again. Wait a minute, please. So let's break the line to everybody can see. So I will apply a conditional to this series, not to whole data frame. So just to this series I have just created. And this data frame will follow the same, this conditional will same this rule. Every time the hour is bigger than 6, I will I will copy the value contained in the column fillet. So I indented here. Okay, this equal must stay here. Okay. Okay, I'm not printing everybody, and I should printing the day column here. Look at that. I created this, initially was empty, and I recovered just the time when this value was, the data time was bigger than 6. The hour was bigger than 6. Every time it happens, I recover this value. But it's not day, because we have some periods at night, for example. So we can do using this. This symbol means, in this kind of conditional, the symbols means end. So I will repeat this, but in lesser than 18, for example. It's important when we use and or, it's important to use parents here and here. And now I fill it just, for example, the daytime, and the others is not a number, or I can put another values here. If the conditional was or, I can use a vertical bar, but this is for and. So now it's some kind of rules. It exists another kind of rules for this type of operations. Okay. So you can do a for statement and recover every position of the data frame, but it's not practical, because it will make your code more slow, and not the idea was Pandas was thinking. Let's see something that we everybody, a lot of people would like to see too, and I'd like to see this information too, is something that, for example, if you'd like to see some information about this whole data frame. For example, I would like to see basic statistic information. So, for example, let's print. I don't need to create a file, a data frame. So fill merge it. Yet I will apply it to this data frame, the method describe. This method describe will calculate for each column of this fill merge some statistics, and will return to us a series that each, it's here, let me open for better visualization. Each variable have a count. Count is the number of variables, valid variables. Mean, standard deviation, mean, max, and quarters, and median, and another kind of statistics, the basic statistics. So, but if you're not in the, if you are not interested in whole describing, you can just put here mean, for example, or standard deviation. These are methods of Pandas 2. We can put, for example, sum, and it will sum every value in that column and returning the value of that column, for example. So let's print it here. And this is very simple because we not need to make any kind of for statement, for example. So here is a sum for most of data. It's not use sum except for precipitation, for example, or LE, for example. But here we have the standard deviation of each variable. Here we have the mean, for example. But for some reason, you are doing some work on, for example, and you must to know statistics, each statistic, for example, for monthly times 10, for example. I would like to see every month mean or every month sum or every month standard deviation for my whole data set or for my whole data frame. I can apply. In this case, I will create a new variable. It's not neat. I can refresh, but I would like to preserve this. I will create a new variable, which I will call fill month, and the fill month will be a result from the fill merged point resample. Resample will reorganize or resample the data into a row. I can use here a lot of kind of rules I would like to see. For example, I can see monthly row, so I put here M. I can put here yearly. For in this case is annual, so is A. I can hear this, for example, weekly. I can put here double. So I will, in this case, I will use the month, but I would like to inform him what rule I will put here. So every month, for example, for this data frame, I would like to see the mean. So I will print this result to CSV. Here. And we will see sorry.
Lucas, some people are just asking for them to see all the code because some of the part is going inside the console of the Spider.
Oh, sorry.
And also you have a specific question here. Dilara is asking if it's better to use, now I don't know the name, but aquele that E or a for command.
Here, the statement.
Yes.
About
I will copy and
commercial E.
Yes, commercial E or a for. Yes, on line 44.
Let me see the question. I did not understand. Where is the chat? I cannot see chat here.
I put again for you on the chat the last message.
Okay, in this type answering. Sorry. In this part, using a line statement, inline statement, we cannot use and. It will not be recognized. We should use the e-commercial. If you use into a for statement, if or equal or ands, or so. In this case, you should use and, or, equal, different, equal. In this case, the program do not recognize the comment and do not recognize the comment or. In inline condition, it's necessary to use E or vertical bar. Okay, you can use equal normally, as normally. You can use equal. You can use different. You can use bigger, lesser, no problem. But this and or you should use here in inline situations. You must use this. Okay. Let me see the file tree that I just created. Look that. He was into the month, that month of my data frame, and made the mean of this and put a marker, and this marker is always the last day of that month. You can change it. It exists some functions to change it. If you have more time at the end, I can comment about this. But the default options for pandas is always using the last day of that period. Weekly, monthly, yearly is always the last. So here we have this month of this year have this mean. This month of this year have this mean, and go on. But for example, if you would like to, for example, for precipitation is a data that in general we not use the mean. In general, we use the sum of that month, for example. So for precipitation column specifically, I can change the value. I can refresh PF1 equal. I will do the same function, but the operation will be sum, and of course I would not like to do it with all variable. I would like to do it with just column PF1 and PF3. So everybody was calculated on mean, but for precipitation, I would like to sum the month value. So in this case, the month, the precipitation was done. Note that it's not a seasonality graphical, for example. It's just month by month values. I will talk about in some minutes. So let's recover here. So for precipitation, we have bigger values now because it's the sum of the month. Okay. For example, I can create new lines. For example, in my month values, I can, for example, calculate the TA era 1 max, for example, which means I will recover the max value of each month from my original data set. So data frame in this case. So I can recover the max. And so it will create a new row, a new column. In this new column, it will put the max value from each month of this data set. So it's useful too. You can use it by each. You can use from standard deviation, you can use from max, mean, every single operation that you can imagine. So this is for a month. You can do it for a year. Change here, change here. We can do it inclusive for irregular periods, and we can do it for example, hydrological year. For example, in hydrological year, we started our year in 1st October and ending it on the September. So in this case, we just let down. So fill, for example, I will create a new variable, which I will call hydrological year, for example, and instead use month, I will use annual, but not the civil calendar annual, but hydrological year. Here I am informing when I would like to finish. And here I can put every month of the year, for example, January, February. You can inform would like. For our case, in United States, for example, the hydrological year has this period. In other locations, maybe it is different. So let's put it sorry, I made something wrong. Let's see what happened here. I have some wrong here. Line 2. Okay. Here's the wrong. I forget to inform what variable I would like to calculate the max. Here, 1. Look, that key error, it not identified 1 because it not exists. So now all the calculation was done. So in this file, we have the T error max for each month. In the file 4, we have the, what happened here, not 4. I write the wrong variable. And now and here is the year. In our data frame just have 4 years, so this year it's presented here as the end as marker. Important to see that if some years, for example, is not completed, the available variables will be used. So if your year start in January and finish in February, the whole year will be assumed as this data. So it's important to know how your data are working. We can do it for seasonal periods, for example. So instead use A, you can use, for example, Q. The Q means quarter. So it will the year will divide it in 4 equal parts, and the last one is finished in September. So the next one, the first one starting in October, November, and December, and go on. So for example, seasonal period, for example. And here we can put 5. What else more? Okay, but for this data set, for example, when I have the month data, which I calculated the statistic mean and sum and max using a month periods, I can organize it into the months, group it into a month. For example, January, what's the mean of all January of the data set? What's the mean of all February of the data set? And made seasonal plotting, for example. So let's create a new variable, mon g. This will be applied using, I can use the original set or the mean set. It can be roughly slightly different, but let's use this. So I will create the G here means group it. I will apply the grouping formulations. So I will apply the group by and I must inform him what's the rule again. So the rules in this case, I would like to organize it by month. So I must call some index, and the index in this case is the month, which means that every month will be calculated as some rule. What rule? Mean, for example, or sum for precipitation, for example, or another. But this index is from here, from which data? In this case, must be the same that we are grouping. So if I'm grouping through the few month, I will searching the few month, index month, and now we can see this 3 grouped here. And again, I should correct the values for the precipitation, because precipitation I would like to use mean. So be careful that. In this case, I will not do it now, but it's important to inform. So let's see the difference between the out file 3, that is a mean of each month of the series or data frame, and see what I created here. In this case, I have from this whole data series, I created a month, a January means, a February means, and go on for every column. And you can use here, for example, instead use month, you can use year. No problem. You will be the mean of each mean by years, but here this is the year, and you can do it for every variable. We can do it using, for example, the day, but it's not scientifically, it not inform too much things, because this variable do not variable based on the day, but based on month, for example, I think. So note that here the variables, the index is are numbers 1, 2, 3, 4, 5. You can keep it to plotting, and you know what is your month, but we can put some names for your month too. So let's change the index. We can change the index of this variable. Put in here the corresponding values, that is 12 values for each month, January, February, March, and go on. But it's necessary that contains the same numbers that contain there. I created previously this, I will copy here. And we will see why I put in this way, because January, July, and June have the same value. If you know that it's the order of the month, no problem. You can plot it without no problem. But if you would like to recover some lines for some calculation, it will create some kind of conflict. So important to identify different variables. And I can, for example, to refresh my variable now and sort, for example, my values. But for sort, I must inform, but based in which column I would like to sort. For example, double T era 1. So I will sort my files based on TIA era 1. Let's see what happens. Look at that. TIA era 1 was sorted so January, February, March, May. So where is April? April goes there because I sorted. If I did not sort it, the original sequence would be maintained. Let's be more. Let's see. Note that my index has no name in this case because I create a new variable and I create a new index. As I create a new index, the name of my index does not exist anymore. So let's create a name for this index. So index.name equal row of. So I think, of course, Pandas has a lot of another.
Lucas, we have more 10 minutes, 12 minutes. I wonder if maybe you can open for questions and direct questions to you.
Yes. I was ending, including because I know that the time was ending, and I would like just to present to you a getting started tutorial for Pandas that have data to training and a lot of another informations. I think this is the basic that can raise some curiosity, but Pandas goes more further into the analysis of data. So sorry if I did not present all the expectations, but I think it's the basic and help us to start at least. If you have any question, I'm here.
I think all the audience, and now you can open your camera, open your microphone, and you can do direct questions to Lucas. Baharimi made a question. It's not a Python question, it's about gross primary production. I'm not certain to say this here now. I think Gilberto can make a better question, but I think gross primary production is accumulation of CO2.
Yeah, this will be different for each temporal resolution, right? And for instance, the yearly resolution is the unit is actually converted to grams of carbon. So I will post a link here with the information of what are the exact units for each period. But you're right, Andrea. There is differences in the aggregate in how we aggregate these data for different resolutions.
You talk about accumulation. I forgot to talk about another common in pandas, very useful, especially for these variables that you must know how the data accumulate through time. You can, for example, accumulate all your data frame or just some variable here, using the CumSum function. So this CumSum will accumulate it through time, not just month by month, for example. So I think it's very useful. I forgot to tell you.
Well, I really enjoyed this, and I want to say, in addition to any questions that people might have specifically about Python, if you want to share how you would like to use FLUXNet data, we might be able to provide some comments on other strategies in Python that you can look up, so you can continue learning afterwards. Plus, it gives us a chance to get to know you guys too.
Gabriela, do you remember the link Hausen sent for? There was a list of resources.
All the packages. Yeah, Andre had shared it, I think, at the very beginning of the chat, so it is on our blog. I can dig it up unless somebody on the team already has it.
I put the Raphael, the matplotlib part of the course video recorded in the Google Drive, and I will send again in the chat the link for download the video. And I think all the materials we can provide a link to download. I don't know if you can email directly, or we can put in a blog in the FLUXNet blog. We can put an article with the links to download all the scripts.
I think that would be a great permanent resource for folks. In addition to what we discussed today, this might be what Fred was referencing to, which is a past blog post we had, which was like a rolling list of software packages. So you can reference that for, just additional information.
I think we can write an article in the FLUXNet blog and put all the links, because I will save the chat here, and then we can go back and take all the links and put in order and put it on the blog for everybody to download.
Yeah, that's great. So the best way to hear about that blog, I would say, is to join our email list if you haven't already, or follow us on Twitter. Those are the places where we tend to make the most recent announcements, so you'll get that information right away. Okay.
Gabriela, if I can add just a quick note here, I got a question that I think is of interest to everyone, asking about postdoc positions and things like that. I will direct that you guys should check out the postings in the community mailing list. So there is the FLUXNET-ECN. There's lots of postings for positions there, PhD positions, postdocs, and also the general FLUXNET mailing list. I posted the link here where you can find information on how to join all of those mailing lists. Lots of positions are posted there. We actually just had a interesting discussion on that mailing list, on the FLUXNET community mailing list, about someone who found all of his positions through the FLUXNET mailing list. So it's a good mailing list to keep an eye on.
Yeah, it's pretty active. And if you're looking for, I mean, because we don't really have, you know, if you have a Python question, you should totally jump in, because at this point we're kind of just giving you little announcements and stuff. So if you enjoyed this and you want to keep engaging with us, we do have our monthly webinars. This was in place of that, but in June we're going to have a land atmosphere interactions workshop, so you can join us there. We're going to have a networking opportunity so we can have more like one-on-one engagement with each other as early career students. That registration is going to close on May 25th. So I'll drop the link in the chat. And then the AmeriFlux group, which is like a node of the FLUXNet group, wants to tell you that you're welcome to join them in September. And that we're going to have like recruiting breakout topics. So that's a point where you can submit a topic that you would like to talk to other scientists about, like emerging research fields, collaboration opportunities, or how to grow our community or data products.
I think Frederick can do a spoiler of the iLeaps event also.
Yeah.
So we would also be having a Twitter conference sometime during the year where we basically give you a hashtag, and then you just put your poster on Twitter and then use that hashtag, and people can find your poster from anywhere in the world, and then they can comment, give you feedback, and so on. And so again, join the mailing list, and we'll get to you when that comes up live.
Yeah, there's a lot of good stuff. That's going to be in August, right?
Yeah.
August. Mm-hmm. Cool. A lot of ways, lots of ways to join. Yeah, big thanks to Lucas. Drink a lot of water after. That was a lot of a lot of talking. Andrew says that you love Python, so you can go for it.
I want to thank Lucas very much, because as I said, he loves Python, and I'm sorry to have to interrupt him today, because I know that if I let he will talk about Python along the day and night. And
yeah, we could see that. I was drinking water more than him. So, thank you, Lucas.
Okay, thank you, and thanks for audience. Thank you for your patience. Thank you for your inviting. For me, it was a great opportunity to talk here, and I really like using, as you can see, Python, and I see that a very useful tool. So I'm here for another questions if I can respond, and thanks again. So I'm very happy to share with you and participating the whole event, including yesterday.
We'll have to invite you back. Well, are there any other comments or announcements, or would you want to wrap it up?
Sorry?
I said if there's no other comments or announcements or questions, we can wrap up the recording, I suppose.
As a complement, I saw many people asked about remote sensing libraries and gap filling methods, and Gilberto posted some links, and you can go directly by email to Lucas, because I know his PhD dissertation, he tested like I think 5-6 types of gap filling method. So he's an expert in this but you can start a conversation, and he also uses a lot of remote sensing.
We always call me expert. I'm not expert in anything, but okay.
I'm gonna be calling you guys for sure.
As part of my, just for clarity, as part of my dissertation, not the whole, not the main product, but my recent publication was in proposing a new gap filling method, and I comparing them with another classical gap filling method for LE data. So I use 5 or 6 stations from AmeriFlux data, and all the programmation was done using pandas. And I tried, and including I use the R package calling REDProc. That's very useful. People use a lot in our community. So what's my biggest experience on pandas today, up to date.
Having worked with REDProc, what draws you more to using Python? Do you think it's just a matter of preference, or did you find like a service that was in Python you couldn't find in another R package?
Let me know if you understand you about preferences. I don't know. I did not run the REDProc directly in my computer using the R, because I'm not a user of R. I used the website of REDProc when you put the dataset inside and download the results. So because I'm not have any preference. Of course, I prefer Python because I know to use, but how to use. But I'm really interested to work with a lot of languages. I don't know if it was your question.
Yeah, I think I know what you're talking about.
I also put on the chat another link. It's another colleague of us here of the Federal University of Paraná. Now he's in California with Marcelo Chamecki, and he coded a Python program for eddy covariance. And so for those who you can download and use that. And I also suggest to the Jacob Nelson that was a presenter yesterday. On his webpage, he has all that methods that he presented yesterday. You have the source codes in Python to download there for partitioning water. So for those that are interested in continuing using Python, you can download these codes, and it's very useful in this area, this scientific area.
Yeah, that's very true.
This man, Thomas Shore, is a really expert in all things you can imagine, not just Python. So he is expert.
He's the expert, yeah.
Yes. He's a great friend of mine.
That's awesome. Cool. Are you on GitHub yourself?
Sorry?
Are you a GitHub user? Do you upload code and share things on GitHub?
Sorry, I'm really.
Yeah. Do you have a profile on GitHub? You know.
Oh, ok, profile. Yes. O que é, André? Fala de novo.
Não, se você sobe teus códigos no GitHub.
No, not yet, because my codes are totally messy.
Yeah.
The time.
But it's hard.
The time is a big problem for me. So I programming carefully, but every time I need to put another new things, I'm doing a messing. So, for example, for this last paper that you made working on gap filling, I intend to prepare a pandas package to put on a GitHub, because I think it's more useful for people. But first I need to be more time, and I am in the last month of my PhD, so I have no time now. So I would like to be more.
Yeah, good.
But it's not for I want not. It's not because I want it. I want not, but it's because I cannot, because